Hello everyone, welcome to this video series on database management system. So in this video we are going to discuss about concurrent execution of transactions. So when the transactions are executing concurrently and there is the interleaving of transactions, what are the different problems that can be encountered? Okay, that thing we are going to see in this video. So let's begin. So I already told you that why this interleaving of transactions is allowed, because to improve the performance, that is to shorten the response time. So for example, if T1 is performing first and T2 is performing next after T1, so for example the T1 transaction is suspended for let's say large amount of time, then T2 will not be performed, right? It will be waiting until T1 is performed. So the response time for T2 is very large. Okay, that's why to shorten the response time, the transactions are allowed to execute in between each other. This is called interleaving. Okay, right. Now, because of this interleaving of transactions, some inconsistencies might be formed. We will see what are these inconsistencies in a few minutes. So before that, let's discuss what is a serializable schedule. So this thing is very important, please focus. So how is this serializable schedule defined is, so if you take a schedule, let's say S, which is having some committed transactions, that means after every transaction the last operation is commit. Such transactions are called as committed transactions. Okay, so the effect of this schedule S is similar to, that means identical to, another serial schedule over the same set of transactions. Okay, so don't worry about the definition, I will explain you with the example. So see here, we have two schedules, schedule 1, schedule 2. So this is serial schedule, right? I already told you in the previous video what is a serial schedule. So because T1 is performing first, then T2 is performing next, this is called a serial schedule. Whereas you see S2, this is not a serial schedule, because T1 is performing for some time, then T2 is performing, then again T1 is performing. Now if you see this, the result of both S2 and S1 over A and B objects will be the same. Okay, so you can take some initial values like A equal to 100, B equal to 100. Okay, and let's say this write operation is doing A minus 50, that means 100 minus 50, so A becomes 50 and B is, and T1 is reading B, that means it is 100, and again let's say this write is doing B plus 50, so it becomes 150. So here also read on A, that means 100 will sorry, not 100, 50 will come, right? Because T1 has modified, so this will be 50, and this right here, let's say it is also A minus 50, that means it becomes 0. Read B means here B is modified to 150. Okay, and write B means, let's say it is again plus 50, write B becomes 200. So by the end of this schedule, A's amount is 0 and B's amount is 200. Now let's see here also. So here also, like here, A is equal to 100, B is equal to 100. Okay, now same thing, A becomes 100, right is A minus 50, so this becomes 100 minus 50, 50, and let's go here, read of A means A became 50, right? Write of A means minus 50, A becomes 0. Now read of B. What is B here? 100. Okay. Write of B means B plus 50, which is 150. Right? Then here read of B. Read of B means what is the B value here? 150. And write of B. Write of B means again 150 plus 50, which is 200. Right? Now by the end of the schedule, what is the amount in A? A is 0 and B is 200, which is same as here. 0, 200, 0, 200. Okay, so we can say that S2 is a serializable schedule. Why I am saying this is serializable schedule? Because the effect of this schedule is same as the effect of this schedule. You have seen now this is 0, 200 and here also it is 0, 200. So that is called a serializable schedule. Now you go back to the definition, read it once, you will understand what is the meaning of this. Okay, right. Now let's proceed. Now when you have this interleaving of transactions, I told you that there will be some inconsistencies, or we can say those things are anomalies. So what are these anomalies? Why these inconsistencies come is because of conflicts. Okay, so what is the thing, why which thing you call it as a conflict means when two actions are performed on same database object, we will call that as a conflict. Okay, when two actions are performing on the same database object, that is called a conflict, right? And these actions should belong to different transactions, not same transaction. Okay, I will show you an example. Just wait. And there are three types of conflicts or three types of anomalies, which are, you can see here, read write conflict are also called as dirty read, and second one is read write conflict, also called as unrepeatable read, and last one is write write conflict. Okay, so I am repeating again. When do we say there is some conflict? When there are two actions which belong to different transactions and they are working on same object, common object, then we can say that there is a conflict, and one of these operations, at least one of these operations must be a write operation. Okay, when both are read operations, there is no problem. Only when at least one, either this or both are write operations, then we can say it is a conflict. So you can see here in the conflicts, it is one write, or it is the other one which is right, or both of them are right. That's why I'm saying it is at least one. Okay, you can see this table and you can understand. So there are two transactions, T1, T2, working on same object. Okay, O is the object here, same object, and if at least one of them is write operation, then we can say it is a conflict. Okay, if both of them are read operations, there is no problem. In fact, any number of transactions, if they want to read, you can allow them. There will be no problem. Okay, fine. Now we are seeing the first kind of conflict, which is write read conflict, also called as dirty read. So when do we say that there is a write read conflict? Means whenever a transaction T2 reads an object which is modified by another transaction T1, which is not yet committed. Okay, that means a transaction is writing on an object and it didn't commit, then another transaction is reading this, which is modified by another transaction. So such kind of read is called as dirty read. Why? Let's see this example. I already told you this example previously. So let's say here this operation changed the value of A, which is 100, to 50. Okay, transaction T1 changed the value of A from 100 to 50, which is being read by transaction T2. So if you see here, this transaction didn't commit. Okay, it is still pending. Now T2 has done whatever operations it want on A, and it has written back the value, and it committed, and it has left. Okay, now let's say after T2 has completed, here there is some system failure and this entire transaction is aborted. Means A became again 100. It is not 50. But this transaction T2 has taken 50, right, which is wrong, because it should be 100, right? So this is an example of write read conflict, also called as dirty read. So why we are saying dirty read means, because T2 is reading something which is not committed. Okay, whatever value T1 has written, it is temporary, it is not permanent, because it didn't commit. It is temporarily stored somewhere in the buffer. Okay, so that's why this is called as dirty read, and this conflict is write read conflict. Now similarly, next one is read write conflict, also called as unrepeatable read. Okay, now you can see here, when transaction T2 modifies the value of an object which is read by transaction T1, while T1 is still in progress. Okay, such kind of read is called as unrepeatable read. So let's see an example to better understand this. So this is read write conflict. Okay, so T2 is writing on something which is already read by T1. Okay, transaction T2 is writing the value of an object which is already read by T1. So you might be thinking, what is wrong with this? Okay, so let's take an example. So you have some urgent need and you have to spend some money, and in your account, let's say when you read the balance in your account, let's say there is 1000 rupees. So you are using a mobile app, some bank app, and you have read the balance in your account, it is showing 1000. Okay, meanwhile, before using that 1000 rupees, you are checking something in the mobile. Before doing the transaction, you are checking in the mobile. Then your family member, maybe your wife or brother or sister or someone who has access to your account, they are using maybe net banking or some other means, they are using this 1000. Okay, so when they access, they also get 1000, and let's say this write operation is doing minus 1000 and it becomes 0. Okay, this modification is, they have withdrawn the 1000 rupees and your balance became 0. If you see here, the object is same, A, right? Now after checking in your mobile, after seeing some information, you again came back, and this time when you refresh the app, your balance is becoming 0. Now you don't have any money to spend, but your task is very urgent. Okay, and you are panicking. right. So this is the bad thing with read write conflict. Okay, which is also called unrepeatable read, because whatever value you have read before has changed when you read again. That's why it is called unrepeatable read. So here you will get 1000, and here you will get different value which is 0. Right. So let's see the third and final conflict, which is write write conflict. So by this time you might know what is the definition of this. So here, a transaction T2 is overwriting the value of an object which is already modified by another transaction which is still in progress. Okay, right. So here you see this, a write action which is performed without first reading the value of an object is called blind write. Okay, now let's see an example to understand this. So here is the write write conflict. This is called write write conflict, and here if you see this, here it is called blind write. Why it is called blind write means, because this transaction is writing onto object A without reading it first. It is not reading, it is blindly writing. That's why it is called blind write. So what is the bad thing about this means this update will be lost. This update will be lost. Why means, for example, let's say the result of this operation is the value of A is 100. Okay, and this is not actually being read. The value of A is 100, and T2 is coming and making this 200. Okay, or let's say do something else. This is doing 100 and this is making the value of A as 0, right? And after some time this transaction has failed and it has rolled back. Then what happens to this update of 100? It will be gone and it will be shown as 0, which is inconsistent, right? So whenever there is a write conflict, the write done by the first transaction will be lost, gone. It will be overwritten by this value because this is not saved yet, right? It didn't commit. Okay, so this is write conflict. So there are 3 types of conflicts: read write, also called as dirty read, read write conflict, which is also called unrepeatable read, and third one is write conflict, which might have blind writes. Okay, right. And finally, now let's discuss schedules which involve aborted transactions. Until now, in all the examples that I have shown you, all the transactions are committing, right? Okay, now whenever there is a system failure, I told you that the transactions will abort and whatever actions are being already done, they will be undone. So this property is called atomicity, right? Now again, they are redefining what is a serializable schedule. You can go through this, you will understand it because you have already seen it. Okay, and I told you that whenever there is system failure, you will undo the actions, means whatever actions are done, you are undoing. Okay, but this might not be possible in all situations. Okay, this might not be possible in all situations. Why? Let's see this. Okay, so if you see here, again we are seeing 2 more types of schedules. One is unrecoverable schedule and second one is recoverable schedule. So what is called unrecoverable schedule? Okay, a schedule in which actions of transactions cannot be undone. Such kind of schedule is called unrecoverable schedule. So the definition is very straightforward. Okay, if you can't undo the actions of a transaction which are already performed, that is called unrecoverable schedule. The opposite to this, if you are able to undo the actions which are performed by transactions, that is called recoverable schedule. And the property of recoverable schedule is, you can see here, the transactions commit only after all transactions whose changes they read commit. Okay, now let's see the examples to understand this better. So this is an example for unrecoverable schedule. Why I am saying this is unrecoverable schedule? If you see here, T1 has performed read and write on A, which is being read by T2. Then after T2 has committed, here T1 is aborting. Aborting means all these things are undone, they are removed. But if you see here, the whatever changes T1 has made, it is already read by T2 and it has committed. So you can't recover this schedule. So that's why this is called as unrecoverable schedule, because the changes has already committed, saved on the hard disk. And example for recoverable schedule, if you see here, T1 is performing the first 2 operations, read and write on A, and the action which is performed by T1 or modification which is performed by T1 is read by T2. After it has performed up to here, it is still waiting for T1 to commit. If, for example, due to some system failure, T1 has aborted and these things will be undone, because T2 has not yet committed, these things can also be undone. Okay, that's why the schedule is recoverable. If you see here, T2 is committing only after T1 is committing. So this schedule is recoverable. Okay, so that's it. This is about concurrent execution of transactions, where you have seen what is the serializable schedule. Okay, and you have seen three types of conflicts: write read write, and write write conflicts. And finally, you have seen the concept of schedules involving aborted transactions, where you have seen two types of schedules: unrecoverable schedule and recoverable schedule. So that's it for this video. Please like it and share it with your friends, and also subscribe to my channel for latest notifications. And if you have any doubts, comment it below the video. I will respond.